Good morning, class. Welcome to grade 11 maths on Wednesday of our fourth week together. Remember, I am Miss Shabalala, and I'll be your teacher again today. Okay? Today, guys, is a special day for some of you. It's a not so great day for some of you. I'm particularly sad, but it's the last day that we are doing trigonometry. And from here on out, we're going to continue to a new topic. Welcome to everybody for joining us today, and thanks for joining us today. To my regular squad, welcome as always. As you know how things work, whenever we could possibly have some newbies, we make announcements, right? So our announcement is our rules of engagement that speaks to saying, please let's respect everyone because we're all here to learn. Number 2, there's no such thing as a dumb question, so please ask away. Number 3, please raise your hand and you will be unmuted when you can ask. Number 4, please keep your cameras off, your cameras and videos off. Guys, you might have seen from yesterday, we have bombers that come into our classes to release unsolicited videos and stuff and use vulgar terminology in our chats. Number 1, I'd like to sincerely apologize to you guys for that. Number 2, I'd like you guys to know that it's obviously not intentional on our part. These are what we call bombers, and it comes with the territory of using Zoom. Okay? This is part of why we are managing things differently now by saying that you have to sign up to our newsletter to get access to the links for the class. Because the fact that we publicly give out our links is what gives ammunition, or what gives ground to the bombers to come and disrupt our classes. Sincere apologies for that inconvenience, guys. These are the things we are working around to make sure the learning experience improves for you guys as we go along. Okay. Number 5 says, please type your questions in the chat if you are shy to raise your hand, and I'll gladly answer you as well. Please just be able to reference your question when you do type your question in the chat, because we do have quite a few questions today, for example. We will not tolerate vulgarity because this is a learning environment. And this goes back to me saying sincere apologies, guys, that you would be exposed to any vulgarity in our chats. It is the bombers. All right. Next, please do not take the opportunity to learn away from someone else. And that is what I feel the bombers do. But I appreciate you guys for maintaining focus and for us continuing with the program. Lastly, please share the link with your friends. And the link that I'm referring to this time around is the link to sign up for the newsletter, where the link to the class will be released. Okay. Anyway, those are our rules of engagement, guys. I'd say today is our last day of trigonometry, so the program is relatively smooth. Taking it easy. We're taking it easy today as we wrap up this topic. Okay. So today's class really it's centered around us getting our homework questions done. Our homework questions are another way in which trig questions can be asked. Okay. You can simply be asked to prove something. And that was the center around our questions. After we've done our whole homework questions, I'll be giving you my personal exam tips that I share. My exam tips are based on questions that I've gotten from learners and also from experience on how you see learners going about their work. When we get to the exam tips question, if you have any questions, please drop that to me on the chat and I'll be happy to address that for you accordingly. But as always, if you're really, really afraid to speak here on a public platform, happy for you to throw me an inbox on Twitter. Okay? All right. So this was yesterday's homework, guys. I basically gave you 4 equations and I said to you, prove the following. Okay? I actually found the homework to be very easy given the level of lessons we've been having. I hope you guys found the homework to be easy as well. So when we ask a question and we say, prove the following, right? What we are saying to you for certain is, this statement is correct. Please show how the statement is correct. So when you are proving and you have a left-hand side and you have a right-hand side, your purpose is to either make the left-hand side look the same as the right-hand side, to make the right-hand side look the same as the left-hand side, or to solve both sides of your equation to get them to look the same at the end. Because no matter what happens, they should come out the same. In very rare instances, guys, you find an error in the preparation of the paper, a typo. The difference between a plus and a minus that actually might not get you to your answer, but that is a very, very rare occurrence. This kind of question is usually a statement of fact. I am telling you in number 1 that the cos of 90 degrees minus a times the sine of 20 degrees divided by the sine of 180 degrees minus a times the cos of 70 degrees plus the cos of 180 degrees plus a times the sine of 90 degrees plus a is definitely equal to sine squared a. I'm telling you, if you had to choose a value, a reference angle for point A, let's say you use 60 and you substitute in this formula across for 60, you will find that the left-hand side should be the same as sine squared 60. No matter the variable you choose, your left and the right will equal to each other. So that's the thing about equations. And how you normally find such a question, part 1 would be saying to you, prove the following, and they're telling you this is a statement. And part 2 would say to you, now that you have found this, we'll give you the variable of A and we'll ask you to please maybe use a calculator or not use a calculator to give us the value of this question. And that's how you would get sine B coming through. And part B coming through. And when you do that, you're going to substitute whatever you need to substitute into side 1, and then you will check using side 2, left or right? I hope that makes sense. Remember, guys, I'm happy to take your questions. So in the interest of time, let's just start tackling our 4 questions, after which I'll just take you through my quick exam tips for you guys, okay? Hoping everybody's good and well this morning. To the guys that are fasting, hope you're still all right, okay? And best wishes. Okay, so here's our first one. We were saying in our first question, prove the following, okay? So, I've been asked before by a few people, Jerusha and an anonymous, why do you always prove the left? And I want to reiterate, I don't always prove the left on purpose. I prove the side that I think is not in its simplest form. And sometimes that means you will prove both the left and the right. You'll simplify the left and the right. So when I look at this equation here, I think that the left is not in its simplest form. The right is in its simplest form. So I'll only be proving the left, okay? So here's our equation. And how do we go about this, guys? First and foremost, we can already see we are working with reduction formulae, okay? We are working with our, guys, I don't have a mouse pad again today. We are working with our reduction formulae, okay? So we can already see what we need to do in here. Number 2, just a glance, high level, and you haven't even started the question. You're already seeing that you have a sine of 90 here, and you know that you need to apply our co rule, okay? Where we use co-functions. The sine of the co-function of sine is cos, and vice versa, okay? That applies here as well, and maybe here, and maybe here. Okay, guys, so my next step from this that I did, as I said, I applied my reduction formulae where that is available as a next step. So I said here, the cos of 90 minus A is the same as sine of A. This is our reduction formula, guys. We are reducing, right? Then I took the sine of 20 and I wrote it out in terms of what it would look like as a co-function rule. Remember, it says that the sine of 90 minus x is equal to the cos, right? And it's the same principle then you apply here as well when you say cos is equal to sine, okay? That's your co-function, your co-core rule. And that's what I did here, guys. And I came out with this reduction again, right? At this point here, we know that our cos in the third quadrant is negative, right? So yes, sine in our second quadrant is positive. And we know sine in the second quadrant, this is the second quadrant, is positive. So we're just changing the function, okay? And that is what we look like at the next level, right? We have basically come out to say sine of A times cos of 70 divided by sine of A times cos of 70 degrees minus, because this minus here times this plus is going to give us a minus, cos squared A, okay? From here, we simply solve this against this, and we find ourselves with 1, okay? And it looks something like saying 1 minus cos squared A. And that should ring some bells, because over here, you can see we have our Pythagorean identity, right? Do you guys remember the identity? The identity says cos squared A plus sine squared A is equal to 1. Okay, so simply sine squared A is equal to 1 minus cos squared A. Okay, and that is how we come to our final answer. Okay, what you could have also done in here, guys, could have been, instead of converting sine to cos, you could have kept this as the sine of 20 and made this the sine down here of 20. Okay, so then you would still come to the same point and those would cancel each other out. So in here, guys, that's why I said to you, trigonometry will never give you a heading and say, right, now we are working with reduction formula. Now we are working with the co-function rule. Now we are working with identities. It's everything in one. So here we found ourselves working with reduction formula, right? We found ourselves working with your co-functions, okay? When we found ourselves also working with our Pythagorean identities. In one question, we have 3 trig concepts. So please don't take for granted that just because we are able to split trigonometry up topic by topic, that it is tested topic by topic. Okay? Moving on to the next question, guys. Oh yes, and finally, my favorite bounce on the screen, when we have proven the left side to be equal to the right side. This is something that any of you guys, if you have aspirations to study accounting, this is another thing that you will love to see. When your left-hand side equals your right-hand side, when your debits equal your credits, when your recon balances, that is the same feeling. All right, let's move on to our next question, guys. Our next question was saying, prove the following. And it was saying the sine of 180 plus beta times the sine of beta plus 360 divided by the sine of minus beta times the tan of beta minus 360 is equal to the cos of beta. This was not a mistake, guys. I actually got a question. I found it so cute, checking with me if I saw that this is correct. This is correct, gents. It was not a mistake. Okay, so I'm looking at this and I'm of the opinion that once again, my left-hand side is easier to solve. My right-hand side is in its simplest form. So I'm going to go ahead and solve my left-hand side. Okay. My left-hand side here, we are saying, right, this is the equation itself, and we are already seeing we are reducing. Okay. Okay. We have negative angles. Okay. And we know negative angles just mean anti-clockwise movement. So we are going to reduce and simplify in our steps. Okay. Our next step says the sine of 180 plus beta. This is the third quadrant where sine is negative. So it's negative sine beta. What I did here, guys, I always like to say some of us are much quicker than others. And as I said, we have to be patient with each other in this class, and we must not take the opportunity to learn from someone else. Somebody else could have quickly seen that you can just take out a minus and make this 360 minus beta and continued. But I do the question step by step so that we are all on the same page by the end, okay? So I've taken out a minus from this bracket, okay? So that I can write this equation or this reduction as we normally see it, where you are minusing your known points from your unknown or from your reference angle, okay? So I've taken out that minus. So now we are saying it looks like minus sine of 360 minus beta, all right? Here's our denominator. We have that over there, our negative angle, right? And we've done the same for tan as we've done for the sine, okay? From here, guys, we are going to basically then reduce these two. Sine is negative in the fourth quadrant. This is the fourth quadrant. I hope you all agree with me. Oh, goodness. This is the fourth quadrant. Sine is negative in the fourth quadrant. And so a negative again times another negative brings us to a positive and brings us to sine of beta, right? Tan is negative in the fourth quadrant as well. So a negative against a negative again brings us to a positive beta. Okay, guys, reminder, please keep your videos off. Okay, right. So here we can already see minus sign and minus sign can cancel each other out quite simply, right? You can already see that. But if you can't see it, for step-by-step purposes, I'm going to drag it all the way, okay? Here I have basically taken my tan and untangled it, right? And I've broken it down into its identity, okay? And then from here, then if you say that this and this eliminate each other out, you are saying that you are left with the sine of beta divided by the sine of beta over the cos of beta. You guys agree with me? Right? You know when you divide by a fraction, you are multiplying by the reciprocal. So this then becomes the sine of beta times the cos of beta over sine of beta. If that's the case, we eliminate these two against each other, just like that. And we are left with our final answer of cos of beta. Hoping everybody sees how that works. And here we have proven once again that our left-hand side is equal to our right-hand side. Okay, everybody happy? If anyone has a question in this regard, this is question 2 of today's questions, right, guys? You may ask and reference this as question 2, okay? Moving on to question 3. Question 3 said, prove the following. So we have 1 minus tan alpha times the cos of alpha is equal to the sine of 90 degrees plus alpha plus the cos of 90 degrees plus alpha, okay? So I looked at this, and this was one of those There's scenarios where for me, both the left-hand side and the right-hand side needed to be simplified, right? So I'm going to start with the left-hand side. I'll be simplifying both sides this time around. So I started with the left-hand side. Remember, my favorite rule to you guys is whenever you see a tan, if there's no other tan to cancel it out, then try to simplify it to a cause and sign identity. It's not a rule of thumb that is the end of the world, guys. It's just a method I found that makes maths easier, makes trigonometry easier, because your most basic identities are cause and sign, all right? So same if you have cot. Cot is the inverse, it's cotangent, it's the inverse of tan. And I would advise that you always try to simplify it as an expression of cause and sign. All right. So here in my next step, I have simplified my tan as an expression of cause and sign. So here we are having a subtraction in our bracket. We're having a subtraction calculation. Let's call it a calculation. And we have a fraction. This is basically a fraction, a numerator and a denominator, right? When we're working with fractions, we know that we have to find the lowest common denominator for us to be able to administer addition or subtraction. So this is just a 1. 1 is the same as saying cos of alpha over cos of alpha. So cos of alpha is our lowest common denominator, right? So it'll look something like this when you've blended it. When you're saying cos of alpha minus sine alpha over cos of alpha, right? Over cos of alpha. That's what you look like. And you multiply by your cos of alpha. All right? And then basically then, as you can see, hope alarm bells went off. You can cancel those out. And you will be left with the cos of alpha minus the sine of alpha. This, I'm under the impression, is as simple as the left-hand side can be, right? Then we move on to our right-hand side. Right-hand side says sine of 90 degrees plus alpha plus cos of 90 degrees plus alpha, okay? We are working with a 90 degree, so we can already remember co-functions, okay? Right. Now sine is, this is the second quadrant that we are working with in both cases, okay? Sine is positive in the second quadrant, so this can be translated to cos of alpha, right? Here, cos is negative in the second quadrant, so you put your negative and then you do your usual co-functioning, and you say sine is alpha, okay? So it comes out looking something like that, okay? Comes out looking something like cos of alpha plus minus sine of alpha. Your plus times your minus quite simply gives you a minus. And that's what your final answer looks like. And lo and behold, we have proven the left-hand side to be equal to the right-hand side. And this was one of those instances where we had to put in work in both the left-hand side and the right-hand side. If there's any other way that someone attempted this, please let me know. Maybe we can get some nice ideas of how people think about things. Or if again, you're not comfortable in the class and you'd like me to have a look offline, more than happy for you to contact me in that regard. Okay? Anyone have a question about this? This is question 3 as a point of reference. Okay. Next is our last question, question 4. Question 4 says 1 over cos squared beta minus 1 is equal to minus 1 over tan squared beta cos squared beta, right? So guys, I also looked at this particular one and I said, I feel like both the left and the right could be simplified, right? Guys, sometimes some of us are brave. Someone would actually say, I actually think the left is in its simplest form, so I'll only solve for the right. That's also fine, guys. Remember, maths is a science of logic. The answer, there's only one answer, but there are different ways to get to that one answer, okay? Unless you have a square root, then there's 2 answers. But there's only one answer. but there are different ways to get to that one answer. We won't penalize you for getting to the answer in a different way. It's okay, okay? And I'm even happy to explore with you the different ways that we can get to an answer, okay? So here, I decided from this that both the left and the right are not in the simplest form, and so I will be simplifying both the left and the right, okay? So here we go. Starting with the left-hand side, I'm saying 1 over cos squared beta is equal to -1, right? I think already when you see a 1, when you see a cos squared, you can already hear alarm bells. These are our Pythagorean identities, okay? Okay. So first what I did, again, so that it looks to me like something I know. Remember we had said it's sine squared beta plus cos squared beta, and that's equal to 1, right? So basically now it's like this sine beta has gone that side. So it looks like we've said cos squared beta minus 1 is equal to minus sine beta. We've basically swapped around the 1 and the sine, right? I wanted to see this in the way I know how, so I pulled out a minus over there. How I like to see this is for me to move the cos to that side and the 1 to remain positive. But it's not a big deal, guys. You do this how you see best, okay? So I did that, and the moment you do that, then I know that already in my bracket here, I have a sine squared beta, okay? Just like that. Just simply like that. My simplified version of the left-hand side is 1 over minus sine squared beta, okay? Then I went to the right-hand side, right? And I said my right-hand side, I saw a tan, and I told you guys that I like to simplify tan as a function of sine and cos, right? And I did exactly that, simplified it as a function of sine and cos. And I hope you guys were almost immediately able to see that these two causes could then cancel each other out, and you'll be left with a cos squared beta as a denominator, okay? And from here, you can quite simply see our final answer says -1 over sine squared beta. And lo and behold, the left-hand side and the right-hand side have been proven to be the same, okay? The other option that you have, guys, you could have maybe tried a different way by maybe only working out this side, working out your right-hand side where you flesh out your tan squared beta. Yeah, you could have done that, guys. Please, please, please. I'm going to keep reiterating the fact that you are under no captive or under no hold to only use one method. If you can prove what I'm telling you is correct and you are using a different way, I think we're all actually quite happy for you to do that, right? You could have simply done this, where at this point, at this stage, if you hadn't simplified this and you had stopped over here, right? You could have simply gone on to continue with these steps, right? And you take your minus in here and you really just bring it below the line, guys, right? And then when you do that, you are able to then say, if you have a minus sign of beta, it is the same as the cos of beta, -1. Okay, you could have also just done that. This is question 4 of our homework questions, guys, if you have any questions to refer to, okay? We don't have any questions so far, so I'm happy to move on to our exam tips, okay? I won't be giving you guys any homework today as we prepare to start a new topic, okay? That, guys, was it for trigonometry. Everything trigonometry related is now in your hands. When schools eventually reopen, you are going to revisit the topic, but I hope I've equipped you to be well ahead of the class when the time comes, okay? These are my troubleshoots for your exams, right? Sometimes I've forgotten my calculator at home, guys. When you forget your calculator at home, do not panic. Always, with maths, Maths is a science around logic. Follow the logic that you definitely know. So if you know that you're supposed to be using a quadratic equation, but you don't have a calculator to calculate your final answer, it's fine. You are going to get principal marks for understanding what you are doing. You're going to put your number there. The number will be incorrect the first time, so you'll get penalized for the fact that the number is incorrect at that point. But as you continue to use your incorrect number, you are going to get your marks as we go along in the form of principal marks. Okay? I'm not sure if the answer I'm supposed to use is right. What do I mean by this? I mean, if you have a 7.2.1 where it says to find that, write AD as a function of theta and alpha, like we had yesterday, right? And then question 2 says, use your answer in question 1 to determine such and such. Whatever the answer you found in question 1, you use that answer in question 2. Because you will be penalized for that answer in question 1, but you will not be penalized again in question 2, because you understood the principle that you need to carry your previous answer down and use it correctly at the next level. Okay, guys? So don't worry about that. You will only lose the mark once, and that is the point at which the answer is wrong, not beyond that. When you, or if you get the answer wrong, you carry your incorrect answer through and through until the end of the question. You will not be penalized. Maths is a test of logic at principle. Okay. Next, I used a different rule or a different principle. Always say it's okay. There's only one answer, but there are different ways to get to the answer. Please be happy and comfortable to use your answer. What I'll say to you personally is, please do not try to overthink certain things. Sometimes it's really just a sine rule. Sometimes it really is that easy. Also, please look at the mark allocation, because the mark allocation kind of gives you an idea of how much effort you need to put in. Okay? How much time should I spend on a question? This speaks to what I've just said. Okay? So let's say, so our final exams are 150 marks, right? And we have 3 hours to write. So we have 180 minutes to get 150 marks. That means we can spend about 1.2 minutes on a mark, okay? So if you have a 10-mark question, you basically have 12 minutes to finish that question. I hope that makes sense. Let me mathematically show you quickly what I'm saying. You have a 150-mark paper and you have 180 minutes to write it in, okay? So that means you have 1.2 minutes per mark, okay? So if your marks are 10 marks on a question, you need to try and make sure you take a maximum of 12 minutes to complete that question, guys. If now you are taking longer because you are struggling, stop, move on to the next question. You will not get the full 10 marks, but I can guarantee you, you will not get 0 either, okay? The aim here is to be able to balance the skills. The aim is to be able to go through the whole paper. My big thing, please attempt the whole paper. Yes, your strong point may be trigonometry, but please look at the Euclidean geometry. Make sure you get to it. Make sure you do it. Take whatever 1s and 2s you can get from that section. And when you're done, go back to your strong point and make sure you finish it, because you will have the time to do so. Okay, guys? But always go through the whole paper. Okay? What if I don't finish the exam? It's not the end of the world, guys. Please don't beat yourselves up for not finishing the exam. We're not all at the same pace. Some of us are neat writers. I know I actually used to be quite a quick thinker, but I just wrote so neatly. I would use the entire time. So if I didn't write as neatly as I wrote, I was one of those who could leave an exam within an hour. We're not the same, guys. Please don't be hard on yourselves if you don't finish an exam. The aim is to attempt every question. Even if you don't finish, attempt every question, okay? Beginning to lose concentration in the paper, stand up, step out, go to the bathroom, catch your breath, and come back. It's not even a big deal, guys. Maths is not studied, maths is practiced. So if you practice your maths throughout the year, you won't even need to struggle at all when it comes to time for finals. When you feel like you're losing concentration in a paper, Go outside for 2 minutes. Gather yourself. Pick yourself up. Don't panic. It's normal. It's okay. Right? My final rule to you as your teacher, my wish for you when you are writing any paper, after you have practiced, right, guys? So first, I don't like it when people study the night before or practice the night before. You should take the night before off. The purpose of the night before is for you to eat, sleep, and pray. That's all you do. You practice maths every single day as you go along. Practicing maths doesn't mean you need to do 20 questions a day. 3 questions a day is good enough. Grasp the principles, grasp the logic, and you will learn how to learn maths. Okay. When you've done that, on the day before an exam, your purpose is to eat, to sleep, and to pray. And you're going to come out fine. Okay. So, what's next for us, guys? Functions. Hoping to start a new topic tomorrow. Functions. Okay. So, please prepare yourselves, remind yourselves, pick up on your knowledge. We'll be starting functions tomorrow. Okay. Refreshers from grade 10, guys. Stay with that. Our useful links this time around, because we're at the end of a topic, I've put up the links to the exam papers. What I want to say verbally is we use the Siyavula textbook in the class, which you can also download from the Education Department website. So please get your hands on that. That is what we use in the class. That is where my class examples come from, etc., etc., etc. Okay. Remember, if you need to contact me, if you've got any questions, that is my Twitter handle at _Mbaliti. If you need any information, if you need to know about classes, if you need to know about the STEM school, Africa Teen Geeks is where it's at. And these are all our handles and hashtags on all forms of social media, including YouTube. Right. Remember, guys, we are still under lockdown. We are still under level 4. Please put your best personal hygiene etiquette. Take care of yourselves. Drink your water. Pray to the Muslim guys. Best wishes with fasting. And yes, guys, let's be kinder to each other. We are all in a difficult space. Let's be kinder to each other. Let's love each other. And let's not take anything for granted. I'm Miss Shabalala, guys. Enjoy the rest of your day. Bye.